So that's a photoelectric effect. That's a quick one. Here's some YouTube videos that you might find useful here. Okay, and a simulation at the University of Colorado is also a very nice site to explore. Actually, we're going to do this in the lab. Okay, so let's go for chemistry, photoelectric effect. Where is photoelectric effect? You see it right here. Here's a more okay, so here's a simulation. You can change the wavelength. So let's try 800 nanometers, a very low wavelength, 800 nanometers. Okay, this is sodium. Okay, so here's your emitter right here. So electrons are going to come off from here, and this is your collector over here. Okay, and so if I'm going, so right now I don't have any voltage on those two, but electrons get ejected. It's going to be they're just going to move across. Okay, so now I'm going to have 800 nanometers. Look what happens. I'm going to shine on it. Doesn't matter how intense I make it, I can't get anything. Okay, I'm bringing down my intensity, and instead of 800 nanometers, let's try 400 nanometers. See if we can get something going. I can get a little bit going. Okay. And then if you increase the intensity, you simply get more electrons. Okay, you get a bigger current right there. And how do you measure, let's say at 400 nanometers, what's the maximum kinetic energy of these electrons? Notice these electrons will have different kinetic, there's a distribution of kinetic energies. Some electrons will require more to get out of the surface, right? So what's the minimum energy needed to prevent these electrons from making it to the other side? What you do is you adjust your voltage over here. Oops. Uh-oh, something happened. Something happened to the simulation. Let's try that. Okay, yeah. The lower the wavelength, the more energetic the electrons are. Okay, let me see. I think I need to reload this. Huh? Oh, play. So you can see it's now being, by making the voltage negative, okay, it's repelling the electrons. So the electrons are still going to be ejected, but then because of the negative charge on the collector, the electrons are going to be repelled, so they can only make it this far. So to determine what's the maximum kinetic energy of the electron at this wavelength, which is 400 nanometers, what I need to do is find the minimum opposing voltage, okay, the least negative opposing voltage that will just barely keep the electrons from making it. So I can try negative 0.5. They can still make it? No, they can't make it anymore. And there's still some that make it. Okay, so you play a pricing game here. This is like Price is Right. You can change the voltage until you don't get a current anymore. Okay, and so you can try that for different metals. We're gonna do that in the lab, and we'll try to use that to determine the work function for different pieces of metal.
So to calculate this, I mean, we would have to.
Yeah, actually, yeah, these are very realistic simulations, so you can play with it.
I mean, we wouldn't be able to just sit down and solve that.
What do you mean?
Like the minimum.
No, this is all experimental.
Okay.
Okay. you get different work functions for different metals. But when you plot kinetic energy versus frequency, you'll find they're all going to be straight lines and they're all going to be parallel lines. They all have the same slope. And that slope turns out to be h, the same constant, same value for h is obtained as the h that Planck got for the black body radiation. Okay?
So we cannot calculate minimum?
No, it's a characteristic of the metal. It's a property of the metal.
Can we calculate the max?
The maximum. Yeah, because that would be energy of the photon minus the work function of the metal. Okay. And then if you do a search for Colorado.edu, Physics 2000 Quantum Zone Photoelectric Effect, that's a very nice website also. Colorado.edu Physics 2000 Photoelectric Effect. There it is. I found it. Quantum zone. This is a very nice layman's description of the photoelectric effect. It's in a conversational tone. So that might be something you want to read. Okay. Talks about photons and stuff. And there's an article here at nobelprize.org about the Nobel Prize that Einstein won for his work on the photoelectric effect. Okay? And if you want a more rigorous description of the photoelectric effect, that Georgia State site, Hyperphysics. Hyperphysics, Georgia State, photoelectric effect. Just do a search for that, and you should be able to find there. There's the data for which one is this? Sodium, I think. Yeah, this is for sodium. Okay, so these are examples, and you should be able to find the description of the photoelectric effect, and you should be able to get some literature values here for the work functions. All right, so that is the photoelectric